This is 8th grade, Module 7, Lesson 1 on Pythagorean Theorem. All right, so one thing we need to know about Pythagorean Theorem is it comes with a formula, and this is a formula that you're going to want to memorize. And it's actually not that hard to memorize. It's a squared plus b squared equals c squared. Now, how do you know who is who? When you're looking at a triangle, your C is always your longest side. So this is C. And A and B are your two legs. And in all honesty, it doesn't matter if you mix these up, all right? As long as C is always your longest side, then you're fine, okay? So for this one, we're gonna solve to find out what is the length of this side here without having to get out a ruler and measure. So we're gonna say 5 centimeters, so 5 squared, plus, we don't know what B is, so we're gonna keep it as B squared, equals that C squared, which is 13 squared. Now, you know squared means that we multiply the number by itself. So this is going to be 5 times 5. So we're going to put 25 here, plus B squared equals, and again, this is 13 times 13, which comes out to 169. Now, I want that B squared by itself, so I'm going to move this 25. And since I need to move it to the other side of the equal sign, I take its opposite. So the opposite of positive 25 is negative 25. So I'm going to subtract 25 from both sides. These cancel. My b squared falls down. And 169 minus 25 gives me 144. Now, how do we solve for just b? This is saying b times b gives me 144. So it needs to be the same number twice. And so what we do is we take the square root of b squared equals the square root of 144. Now, when you square the b squared, you just get b. So that's how you solve for just one b. And the square root of 144 is going to be 12. And that's because 12 times 12 gives me that 144. Again, if it's B and B, these numbers need to be identical, the same two numbers. So my final answer here is 12 centimeters. And you're done. All right, let's try example 2. Same thing. This is my long side, so that's my C squared. And so these are my A's and B's. And again, it doesn't matter if you get these ones flipped around. It's okay. So I'm going to say 4 squared plus 9 squared equals C squared. Now, 4 squared is going to give me 16 plus 9 squared is 81 equals C squared. Let's add those two together and I get 97 equals C squared. Now this is saying C times C gives me 97. Well, what are my two C's? I can tell you right now, this is what we call not a perfect square. Nothing can go perfectly into 97. So what you want to think of is what numbers closest to 97 could work. So I'm going to say this number, 97, falls between, and I'm just going to abbreviate between there, 9 and 10. Because 9 is 81, right? 9 times 9. And 10 is 100, 10 times 10. 97 falls right between those two perfect squares. 81 is a perfect square and 100 is a perfect square. So since 97 is right between there, which one is it actually closer to? Is it closer to the 81 or closer to the 100? It's closer to the 100. So our final answer is going to be an estimate. So we're going to say the answer is about, using the about symbol there, which is squiggly equal signs. It's about 10 centimeters long. Because you cannot have an irrational, and this is called irrational when it's not a perfect square. You can't have an irrational length of a side of a triangle. So we just go ahead and try and give the closest measurement possible to it. All right, and that's mostly because if you did square 97 on your calculator, if you did 97 square root on your calculator, you'll notice that you get a really long decimal. And again, when you're measuring triangles, you can't have all that. All right, here we go. First one, Write the equation, solve for the length of side. Same thing. So this is my c squared here because that's my longest side. So we're going to say 8 squared plus 3 squared equals c squared. 8 squared is going to give me 64. 3 squared is going to give me 9 equals c squared. All right, let's go ahead and add those two together. And I get 73 equals c squared. And remember, that's c times c equals 73. There are no two numbers that are the exact two numbers that would give me 73. So this, again, is not a perfect square. All right, and what that looks like is the square root of 73 is what we're solving for. So which two perfect squares does it fall between? So we can say it falls between 8 and 9. Because 8 times 8 is 64. 9 times 9 is 81. So 73 would be right between those. Which one is it closer to? Which one does it fall closer to? Well, I'm going to say it falls closer to 9. Okay? If you were to try to look at it maybe on a number line, it would look a little bit easier to see that. So we're going to say it's about 9 centimeters. And that's my answer. Example 4. Now, example 4 is a large triangle, but the right triangle is right down the middle of it. So we actually only need half of this. So I'm going to redraw it. Since the right square is on this side, I'm just going to redraw it in that direction. But in all honesty, it doesn't matter. Okay, this is 10 inches. There's my right square. And since we don't have any lengths of sides, we're going to say x and x. But when looking at the larger triangle, this whole thing would have been x. So just this portion of it is actually half x. I didn't cut this one in half. It stayed exactly the same measurement of a full x, so that one will stay. Let's put this together. I have half x squared plus 10 squared equals x squared. So half times half gives me 1/4 x squared. 10 times 10 gives me 100. And bring down our x squared. Now what we want to do is subtract this, because I'm going to pair up my two x squareds. I can't combine 1/4 and 100 because this one doesn't have an x. But I do have two x squared, so that's what I'm going to combine. I'm going to subtract 1/4 x squared from both sides, and these cancel. This will bring down my 100. Now, if you remember, this is actually a 1 over a 1. So what can I do to that 1 over 1 to get the denominator of 4? It means I need to times this whole thing by 4. So I wind up with 4 over 4 minus 1 over 4. So denominator stays the same, and 4 take away 1 gives me 3. And then your x squared just follows down below. All right, now I want to get this x squared by itself. So I need to divide out that 3/4. So I'm going to divide out 3/4. These cancel. And if you remember, when you divide by a fraction, you actually multiply by its reciprocal. So I'm going to say 100 over 1, just going to make that look like a fraction, times its reciprocal, its flip. So flip that around. So that's 4 over 3. Multiply straight across because none of my diagonals can get reduced. 100 times 4 gives me 400. 3 times 1 gives me 3. Now, if you divide this on your calculator, you're going to get 1.33.3 repeating, and it's going on forever. Now, if I take the square root of that, it's not a perfect square. What gives it away is we have a repeat decimal, of course. But what two numbers does it fall between? So I'm going to say this one falls between 11 and 12. 11 times 11 is 121, and 12 times 12 is 144. So it falls right between these two perfect squares. But which one is it closest to? It's closer to the 12. So our final answer is about 12 inches. All right, the last three, numbers 1, 2, and 3 are going to be on you. You're going to give them your best shot. Remember, you're going to try and find, if you don't have a perfect square like we did for number 1, example 1, then you need to find out where they fall between and pick the one closest. If you can't tell, then you can draw out a number line real quick and see then, or you can find the median between the two. All right. So hopefully that helps you guys. That will end this tutorial.